Hey, so when we are talking about being continuous, there's a couple different things that can happen algebraically. Algebraically, some of the biggest things that we look for is that from either side it comes and it connects, so they end up being the same point, or they're coming and they do not connect. They do not make the same point. So we're going to look at a couple of equations and compare the two equations to see, do they connect to make a continuous line, or do they not connect? Alrighty, so here we have two equations, 7 minus 2x squared and negative 6 minus x. Those are two lines that we could graph. Now, in a piecewise function, all that this means is that y is this equation only as long as x is greater than 3. So if we have a graph, okay, when x is greater than 3, 1, 2, 3, we follow this line. Well, if y-intercept was 7, it's negative 2x, it's going to look kind of like that, okay? That's what that's going to look like. Then here, this is negative 6 minus x, so that means it's going to come down like this as long as it's greater than 3, so it should come up like that roughly. Or it could come up like that, or it could come up like that. This one could be way down here for all I know. I'm not sure exactly where this point is for either of the lines along that line x equals 3. So what our goal is to figure out, do they connect? Do they have the same endpoint at x equals 3? Okay? So let's do some algebra. Now the algebra is actually pretty straightforward. You might be thinking, Harper Smith, why are we doing algebra in a calculus class? Well, calculus builds on algebra. All right, here we go. This is all that I have to do. All I do is I take 3 and I plug it in for x. That's it. So 7 minus 2 times 3 squared. 3 squared is 9, so here, write it out. 7 minus 2, 3 squared. So 7 minus 2 times 9 is 7 minus 18, which gives me negative 11. Okay, that's for my first one. Let's see if the second one has the same y value. Well, we've got negative 6 minus 3. What's negative 6 minus 3? It is negative 9. All right, so if we graph this to visualize what's happening, okay, we come over and at x equals 3, 1, 2, 3, we have our quadratic equation that is at negative 11. And we have our linear equation that starts at negative 9, which is about right there. Is this graph continuous or not continuous? This is not continuous. If you look, there's a jump there. Okay, since there's a jump, this one's not continuous. No bueno. All right, let's try this one now. Here's another practice problem. Write it down on your paper. Try it on your own if you think you can. Here we go. So I want to figure out if it is a continuous line. Y follows this line as long as x is greater than 2. And when x is less than 2, it follows this line. So we've got a linear and a quadratic equation. All right, here we go. Let's try the quadratic first. 7 minus the point that we want to know if they're the same as 2. So I'm going to do 4 times 2 squared. No, I guess technically the 2 is outside of the parentheses. Technically. Okay, Harper Smith. There we go. Next up, we've got negative 13 plus 2 times 2. Well, I guess I probably should have written that off to the side. I'll write it off to the side. All right, 2 times 2 is 4. Negative 13 plus 4 is negative 9. That is for my linear equation. My quadratic, let's figure out what the quadratic is. The quadratic is going to be 7 minus, let's see, 4 times 4. 4 times 4 is 16. What's 7 minus 16? Negative 9. Ooh, they have the same ending spot. They both end at negative 9. That's the y value. So if I graph this, it is continuous. Since we got negative 9 on both of them, it is continuous. I'm just showing you what it would look like graphically. We have this line coming down. Actually, this one comes up. It's pretty steep. We get over to x equals 2, negative 9. you see that? You can't see that, just barely. Okay. So you got a straight line coming, and then we have this quadratic, and it's negative, which tells me that it is going to go kind of like that. I don't know if you can see that. Slide you back a little bit more. There you go. That's what it would look like all the way down there. Okay. So this one is continuous because it comes up. It is really steep. They do connect because on this case it does equal. Then it comes down. This is continuous. All right, last problem. Pause the video. Try it on your own. Figure out, are they continuous? Is it a continuous graph? All right, you should have paused. You should have your answer by now. We're going to do 8 plus 2 times negative 2 squared and 3 times negative 2 minus 4. Let's see what we get. See, this is going to be 4. 4 times 2 is 8. 8 plus 8 is 16. Here we get 3 times negative 2 is negative 6. Negative 6 minus 4 is negative 10. Is this continuous? No, they do not have the same y value. One graph is going to come down, hit 16. The other one is going to be at negative 10. This is not continuous. This is no bueno. Or not continuous, okay? Not continuous. All right, give it a couple problems down there to try.